Okay, so this video is about um, modes of heat transfer. Okay, so there are three ways heat can be transferred from one place to the other. They are conduction, convection, radiation. Possibly you have heard those terms before. Okay, but what do they mean? Okay, so in this video, I'm going to focus on the first way to transfer heat, which is conduction. Okay, first of all, let me give you some very brief introduction of the three ways of heat transfer. Okay, just imagine, okay, we are this student just like atoms in the matter, and there are three lines of students, and they are going to transfer the energy, which looks like some books, from one end of the queue to the other end. Okay, so there are three ways they can transfer the energy. Okay, um, so how can they do that? So let me give you a brief analogy. Okay, so let's see in the first line, if they try to transfer the energy, the easy way they can do it is just transfer the energy. Okay, like this guy, they pick up the energy, transfer one by one. Okay, like this. Okay, in more animated way, I will show you like, so we pick the energy up right here. So from this guy, it gives to the next guy and to the next, to the next, to the next. So that means everybody involved, but without any bulk movement of the members in that line. Okay, so you see that pretty much they keep the shape of the line, but they transfer the energy by just using the hands to pass through the energy. All right. That's okay. So that's the first way, and this mode is corresponding to what we call these kinds of transfers corresponding to what we call conduction. Okay, so pretty much we conduct the energy from one end to the other, and everybody's involved by and have a touch on the energy. Okay, how about the second way? Okay, so second way is a little bit different. That involves some movements of the students in the line. So first, let's get the first students to pick up the energy. Okay, and this student, he's not going to pass this energy to the next, but he's going to move all the way up. So he carried the energy all the way up to the end of the queue. Okay, so but there's a problem because, then there's a void left in the place by the first students. So that means the queue must move to create the space. So the whole queue, they need to move accordingly so that there's enough space to fill the void and let the first students go to the last. So this pretty much is what we call the transfer the energy with the bulk movements of the members, because they do need to move around to create the space, and some members, they need to carry the energy all the way from one place to the other. So this is what we call the second way of transferring energy, which is called convection. And the last way we are going to do it is what we call the radiation. Okay, and the radiation, the way to do it is just to pick up the energy and just threw it all the way without any movement of the particle to the last one. Okay, so that means you can draw an arrow to represent the movement of the energy, just like this. So there's no bulk movement of the molecules, and it doesn't involve the members in between. So that means those members between the two ends, they're totally irrelevant, so you can get rid of them. So you only need the first guy and the last guy to transfer the energy. Okay, so that's the last way. And for this way is what we call radiation. So that's a simple analogy of the three ways to transfer energy. And we're going to start with the first one, conduction first. Okay, so let's go back to the notes. And okay, so there are some filling in the blank for the passage. Okay, so I think this is a pretty good summary of what conduction is. So that's why I leave some blanks for you to fill in. Conduction in thermal energy transfer along a substance without any, okay, I use that term a few times, bulk movements of the substance. For example, one end of a metal spoon soon feels hot if the other end is placed in the hot cup of tea. Okay, and so if you go to the video link I post here, so please watch it. It's quite useful. Okay, so if you go to that link, let me show you. Okay, and
I imagine holding
so
a match underneath it.
if
And
you
what
see,
we
if
know
you
is
have
that
that one,
that spoon is going to heat up, and
so
now
let me
is
play
a
again.
like spoon. And I
If it
imagine
plays,
holding a match underneath it. Now, what we know is that that spoon is going to heat up, and not just the part of the
yeah.
spoon that's over the match, but rather.
So that's what you will get when you heat one end, then the heat will transfer gradually from one end to the other. Just remind yourself that what happened in our first line is just they pass through the energy one by one towards the end. So everybody involved, but without moving around. So no bulk movement. Okay, but you need every molecules in between to transfer to pass through the energy. Okay, so conduction impulse by which kinetic energy is passed from molecule to molecule. So that means you must have molecules in between two ends. Okay, so there are two ways to see it. One way is microscopic view, in which that there is always from the hot place to the cold place. So in technical terms, it's called hot reservoir or cold reservoir. Okay, and understand that thermal energy flows along the material as a result of temperature. So hot to cold is temperature difference, is what we call delta T. Okay, but how about if we look into much microscopic view, you'll see at the hot end, the molecules moved randomly but at a much greater speed. You see the longer arrow there, and in the cold end, the molecule moved rather slowly. Okay, and so that's why when the molecule move much rapidly, they tend to collide each other at a high speed, and they transfer that kind of kinetic energy from one end to the other. Okay, so there are a few points to note. Poor conductor, normally we call them thermal insulator. So that's the term you need to learn. Metals tend to be very good thermal conductors. So normally metals are the best conductors. This is because different mechanism involving the electrons. So if you are studying chemistry, you know what I mean. So that's what we call metallic bonding. So if you haven't learned that part, that's okay. You just know metals are good thermal conductors. All gases and most liquid tend to be good or bad, poor. poor conductors. Okay, it's not. It doesn't mean they can't conduct heat. It just they are not good at it. But you say, okay, sometimes with boil water, how the heat can transfer within the liquid. Is it because there another way to transfer the energy? Possibly you have already got the answer in your mind, which is convection. Okay, and okay, so there's some examples for that. Most clothes keep us warm by trapping layer of air. Okay, so we know some. So in Mackay, possibly we don't need to wear a very thick um, clothes, but if you go to some really cold place, you know those very thick and made of woolen, for example, they have a lot of space. That means they are trapping air, and the air is a poor conductor, so that's why they could keep you warm. Okay, if you walk around the house in bare feet, the floors that are better conductors. Okay, then you'll feel colder when the floors are good insulators, carpets. So remember, even they are at the same temperature, you could still feel something is warmer than others, like copper always feel warmer than the floor. Like the tile floor, you always feel the copper is warmer. It's because the rate of transfer of heat through conduction from your feet to the ground is different when you are stepping um, onto different materials. Okay, okay. The last one is for the cooking. Source pans conduct thermal energy from through conduction. Okay, that's all good. So let's just try to think about one example which I just mentioned. Gloria places a carpet on the tile floor. After a while, she stands in bare feet. You can see it from the figure with one foot on the tile. So that's one foot on the tile, and the other one is on the carpet. So the other one on the carpet. So she feels the tile floor is colder. So he feels colder. Okay, feels is a very important word. Feels colder. Does it mean you really have the same temperature, lower temperature? Okay, and copper, of course, he feels warmer. So what's the reason for that? Okay, I'll give you like 2 minutes to read the example and try to get your answer. Is that okay? Good. Let's have a break. I'm going to have an online meeting with you guys, and after that, I'm going to resume the video. Okay, so let's continue. And so, what's your answer? Okay, so let's see one by one. If you got A, the tail is a better insulator of heat than the carpet. Is it a fact? Yes, this is a no. This is not a fact. So normally carpet is a better insulator. So this is not a fact. Sorry, this is wrong. Tells a lower temperature than the carpet. I don't think that's wrong because they are all at room temperature. So if you are all at room temperature, there's no way one is warmer than the other. Okay, the specific heat capacity. Okay, we haven't learned this, but I will tell you this is not the answer. Okay. And the last one, the energy transfer from Gloria's foot to the tail is at greater rate than to the carpet. I think that's the answer. Okay. Why? Because we know Gloria's feet, like normally our feet is around 35 degree, let's say. So 35 degree. And how about the tail? The tail should be at a lower temperature, like okay, let's say it's in the winter time, so it possibly only 15 degree of the carpet and also 15 degree of the tail. Okay, so the problem is that there's a temperature difference between the 35 degree and the 15 degree of the tail and the carpet. And so that's a heat transfer. So the heat transfer from the feet to the carpet and to the tail. All right, but since the carpet is a better insulator, carpet is a better insulator than the tail, so that means the carpet will absorb heat from the feet much quicker than the tail. Okay, so if there are two arrows, you indicate the heat flow from the feet to the carpet, that should be more arrows. That means greater heat flow, greater rate of heat flow, I should say, from the feet to the tail, right? So that's why D is the answer, okay? Okay, so let's see the next one. Which metal is the best conductor? Okay, so best conductor of heat. Balls are stuck with wax to, okay, start with wax. So that means the wax can be melted. Okay. Oh, sorry, is that wrong spelling? Sorry. The rods are heated at one end. Okay, so heated at one end. Some of the balls fall off. Okay, leaving some as shown in the Y. So this X is before heating. This is after heating. So after heating, you see that less balls are still attached to the rod. Which label the metal is the best conductor of heat? Okay, I will give you possibly 1 minute. Try to think about the answer, okay? Let me pause again. Okay, what's your answer? Okay, the idea is if you have heating on one end, so the direction of heat flow must along the metal rod. Okay, so it's indicated by the arrows. So the further the heat can pass, that means the better the conductor, and you will see more balls falling from the rod. Okay, so in this way, A has only got one, so that means the heat pass through the rod much more quickly than the rest of the rocks. So A is the answer. Okay. Okay, spoons are made different material placed in 4 cups of coffee, poured from the same jar. Which spoon will be the hottest? Okay, the hottest to touch at NX. Okay, so that means you have wooden, you have steel, plastic, black plastic, white plastic. Okay, so which one you will feel the hottest? Okay, so 20 seconds, I'm not going to pause the video. You can pause it by yourself. Okay, so the answer would be just B. Okay, because this is steel. Okay, steel is kind of metal and others are not. And this is obviously the heat conduction in that way along the spoon. And of course, if you have steel, that means it passes through quickly. All right. So why there are two different plastic? One's white, one's black. Okay, so related to radiation. We will do that later. Okay. Okay, so this example involves convection, which we haven't discussed. So let me skip this one at the moment. Skip it. We go to example 5. Okay, a person holds a glass or beaker in one hand and fills it quickly with hot water. Okay, it takes several seconds before his hands start feel the heat. Okay, why is there this delay? Okay, so there's a delay because there's several seconds. 7 seconds before his hand starts to feel the heat. Okay, so the situation is you have a beaker. So this is a beaker. Okay, and you pull your hands. So let's try to draw a hand. Okay. Okay. Okay, it's not a good drawing here. Okay, so just like pretend you have a hand holding on it. Okay, so while your hand will start feel the heat after several seconds. Why is the delay? Why? The reason. Okay, think about 1 minute or 2 minutes. Okay, let me pause it. Okay, so I improved my drawing a little bit, still ugly. Okay, so so you have water inside. So that's hot water inside. So you have hot water. And you have glass between your hand and the water. Why there's a delay? Okay, so water is a poor conductor, or glass is a poor conductor. Okay, obviously you won't say good conductor of heat, because if they are good conductor of heat, then you should feel then it's not justified to say the delay. Okay, so the thing is, when we talk about the conduction, it must be in context. Okay, so the glass beaker is in contact with the hand. Okay, so I think the better answer would be glass is a poor conductor of heat. That's it. Okay, so the next one will be convections, but I will do it in a separate videos. Okay, so that's for this one. Okay, bye.